All right, here's a little bit of Chapter 5 practice. Let's go through these problems. Number 1, how does the graph of f of x equals the absolute value of x compare with the graph of g of x equals negative 1/2? I know that's hard to see, but that is a negative 1/2 right there. Absolute value of x, select all that apply. So we know a couple things are happening. First of all, that we know the negative is a reflection. So we can see here on C, where it says the graph of g is a reflection over the x-axis. That is definitely one of the ones that is a true statement, because we know that that's exactly what it does. We talked about that yesterday. Excuse me. We also know that this graph, because of the 1/2, is being dilated in some manner. So if you look at your other two options, A asks, is it a compression, and B says it's a stretch. Of course, we see that the 1/2 is obviously smaller than 1, and that just means that it's going to be a compression. So the other correct statement for number 1 would be A. Number 2, the graph shows the cost of renting water skis. Amelia rents skis at noon. How much will she pay if she returns the skis at 3 p.m.? How much will she pay if she returns the skis at 3:05 p.m.? So we can see this is a step function. Let me make it a little bit bigger here. So at 3 p.m., that would be right here, right? Right here, and we can see there that she would be in, since that's a closed circle, that would be $25. But it looks like that's the threshold, because after 3 p.m., so 3:05 would literally be right after 3 o'clock. We can see that the price goes up $5, so that would be somewhere right here just after 3. And so the cost would be $30. The applications of the step function we talked about. Moving over to number 5. If f of x equals 2 times the absolute value of x is graphed on a regular coordinate grid, does the graph form an acute right or obtuse angle at its vertex? So we talked about that 2, since it is larger than 1, that's a vertical stretch, and what's going to happen is, like normally our graph is here, right? That's just going to take and make that graph, it's going to stretch it upwards, so it's going to do this right here. So it's definitely going to make it an acute angle. Number 6, find the vertex of the graph and tell whether the graph opens upward or downward. Now remember, the vertex of the graph, that's us moving left and right and up and down. So we can see here that it is being moved to the left because of this +2 here. So we know it's moving left 2. So that would be a -2. And we can also see that there's nothing being added or subtracted outside of the absolute value. So it's not moving up or down. It only moved left 2. So the vertex is at -2 and 0. We can also see here that the number that's being multiplied times the function is a negative number. So we know that's a reflection, just like we talked about back on number 1. So that would be a downward opening absolute value. It's going to open down. Number 7, find the vertex of the graph. So again, same kind of question, but here notice on this one we're subtracting the 3 outside of the absolute value, and there's nothing inside of the absolute value that's being added or subtracted. So this time I don't move left or right any. Again, nothing's being added or subtracted inside the grouping symbols. But the -3 means that my whole graph is going to move down 3. So then y value would be -3. Here we can also see that the number that we're multiplying times in the front is a positive number, and that means that would be an upward opening absolute value. All right, number 8, they want us to write the equation for the graph. So we obviously know it's going to be an absolute value here, and we can see, change the colors a little bit, that remember how we talked about how the number that you're multiplying times the absolute value is basically the slope. So I can see here from my vertex that it goes up 1 and over 2, right? Up 1 over 2, I can see that. So I know that it's going to be y equals 1/2 and then absolute value x, right? Because that is the slope of each one of those sides. Now I know it's not going to be a -1/2, because remember, all the negative does is it reflects the absolute value. All right, so we can also see here that the graph obviously moved to the right 1. So since it moved to the right 1, I know I'm going to be adding or subtracting inside of the grouping symbols, And remember, the adding and subtracting is the opposite operation. So instead of plus 1, that would actually be a minus 1 inside of the absolute value. Number 9, Taylor charges $15 for the first hour of dog walking and $10 for each additional hour. And then we have Lucy down here, and here's Lucy got all complicated, and that's how she charges. And here you can see the restrictions between 0 and 2 hours, 2 and 4 hours, and more than 4 hours. That's what she charges. So it's asking who will charge more for a 2.5 hour dog walk, Taylor or Lucy, and then how much more. So we can see here that Taylor is $15 for the first hour, right? So that's $15 plus $10 for each additional hour or fraction of an hour. So that's actually 2 more hours, right? For each additional, that's kind of like we would need to round that up to 3 hours. So 2 times 10, right? So this, because the first hour, let me make sure you got this. The first hour is the $15. One of these $10 is the second hour, and then the second $10 is for that additional fraction of an hour. Okay, so what do we get? That's what, 15 plus 20. So that would be $35 for Taylor. Now we can go make that all algebra if you want to, but no reason for that. Now figuring Lucy's, even though it looks more complicated, is actually a lot easier. We know that 2.5 is somewhere between 2 and 4. Right? So her rate is $10 times how many hours? So 10 times 2.5 would be $25. So in this particular case, Taylor actually charges more by $10. All right, number 10. I feel like we did this one. It looks really, really familiar. Drew crosses the county line when he drives from home to work. And then here we have the function, and we can see that, you know, we see his time is the x-axis, his distance from the county line in miles is on the y-axis. It says, over what interval is Drew's distance from the county line decreasing? Now, we didn't really talk about that, but I just kind of wanted to point this out because we are going to need it for number 11 here in a second. Decreasing is obviously going down, right, from left to right, like we read. So I can see here, from left to right, it's right there. So as from 0 to a half hour, his distance to the county line is getting smaller, where at the half hour mark it looks like is whenever he reaches the county line, and then his distance is going to start increasing again because he's driving away from it. And then if we look at number 10, it says how many miles does he drive to work? Notice here we're counting by 5s, it looks like, so this would be 25. So if he drives 25 miles to the county line and then 25 miles away from the county line, he has quite a commute from work. It would be 50 miles. All right, number 14. What kind of function is written? So this f of x equals, and notice how it's got the little brackets on the top. Okay, that of course would be the ceiling function, right? Remember, the floor function has the little brackets on the bottom, and it rounds. I hate the fact that it says rounds, but it moves the numbers up to the nearest integer, okay, right? Because it's a ceiling. We know that it goes up. So the graph of f of x equals the ceiling of x includes the point 5.3 and 6, because 6 is the next largest integer after 5.3. Ooh, I hate to use around. Ooh, that hurts my feelings. Okay, number 16. Which function has the same graph as? So let's look at what's happening in this function. F of x equals 8 times the absolute value of x minus 2 minus 1. I can see, sorry, as I was saying, f of x equals the absolute value, 8 times the absolute value of x minus 2, and then minus 1. So we can see what's happening in this problem is it's being vertically stretched by a factor of 8. And then it's moving to the right 2, right? And then it's moving down 1. So that means that obviously the graph that I have also has to move right 2 and down 1. And I can see immediately, like the only one that's an option for here is B, right? Because graph A moves left 2 and down 8. This one moves right 8 and down 8. This one moves right 8 and down 1. So that all of those are not the same. And if you look at in the front of the equation, 2 times 4 is 8. So that would give the same dilation. So B is the correct answer for number 16. Number 18, which graph is shown in the, which function is shown in the graph? Oh boy. Okay, so first of all, we know it's definitely not A or B. You can see that this graph is definitely not symmetrical, right? The right side definitely has a flatter slope than the left side, so not A and not B. This here is a piecewise function. All right, now if you'll look at the two options they actually give you, I don't have to figure out the function. They give them both to me, right? I have a negative 0.5x plus 1 and then 2x plus 1. Okay, so let's talk about how we know which ones are which. So like the negative 0.5x plus 1 has to have a negative slope. So that has to be the left side because that's the side that is going down, right? That's your negative slope. Whereas the 2x plus 1 has a positive slope of 2. Oh, dude, I just did that backwards. Just did that backwards. Y'all. Yeah. Samuel, don't laugh at me. Okay. I said it backwards. Okay, one more time. Let's try that again. From left to right. I said from left to right. The negative 0.5x plus 1, that goes down from left to right. That obviously is this side. Gosh golly. I am smart. It's not all the time. We make mistakes. Okay, so the big giveaway there for me was 0.5 is not as large as 2, right? So that's going to be the flatter of the sides. And again, from left to right, that's going down. Okay, here we go. And then the 2x plus 1, as I was saying, is going to be the left side because that is going up from left to right. And it is a steeper slope too. The 2 gives you a steeper slope. So what we've got to figure out is which restrictions are correct. That's what we're down to figuring out because of good old multiple choice here. Okay, so greater than 0. Think about greater than 0 is obviously everything bigger than 0. I'm looking at this one right here. Well, here's 0. Everything bigger than 0 is this away. And that is where my blue graph is. Whereas if I was looking at this one right here, less than 0 is to the left. That's going to be this way. Well, that's not the side of the graph that I'm on, right? So the answer is C here for number 18, because again, greater than 0 is the right side of the graph, and less than or equal to 0 would be the left side of the graph. And that's where those two pieces are, respectively. Okay, last one. What is the average rate of change of the number 18, the one we just did, over the interval from -3 to -1? You're just finding slope, guys. I know we kind of sort of talked about the average rate of change, but we didn't go over it, but we know how to do slope really well at this point. On -3, that's right here, and -1 is right here. Let me do some erasing right here. Go away. Okay. So -3 is here, right, and -1 is here. So it's asking this part of the graph right here, what's the slope? Remember, average rate of change, just slope. Probably shouldn't have done all that marking, but here we are. Again, -3 was here, -1 is here, so that's why I'm only looking from here to here. So my slope is rise over run, right? So that's 1, 2, 3, 4 up, and 1, 2 right. 4 up and 2 right. So it's 2, right? Rise over run. So the rate of change is 2. There you go.